We need to obtain the derivative of y with respect to x whenever x and y are given in its parametric form. That means x and y are both depend on the parameter t. So let's begin. We'll start with whatever we have been provided with. So here we begin with our x function, which is given by t plus 1 over t whole raised to the power of a. So here what we'll do, we'll take the derivative on both sides with respect to t. Now here on the right hand side, what we can do, we can apply the power rule since we have a constant as the exponent form. So that means we have a times t plus 1 over t raised to the power of a minus 1. But we'll also have to use the chain rule. So we'll take the derivative with respect to t of t plus 1 over t. Right. So let's simplify it. So we have a multiplied to t plus 1 over t raised to the power of a minus 1. Now derivative of t plus 1 over t, its standard value, which is 1 minus 1 over t squared. We're going to label this as equation number 1. So this is the value of derivative of x with respect to t. Now coming to the second function, which is given by y equals to a raised to the power of t plus 1 over t. Now here we'll also take derivative on both sides with respect to t. Now we'll have to use the formula here that whenever we have derivative with respect to t of a raised to the power of t, so this is given by a raised to the power of t multiplied to natural log of a. So in our case, we have t, which is t plus 1 over t. So that means our derivative will be a raised to the power of t plus 1 over t. We'll have the factor log of a multiplied to it. But since here we have t plus 1 over t instead of t, so we'll use the chain rule. We'll multiply it to derivative with respect to t of t plus 1 over t, which is going to give us a raised to the power of t plus 1 over t times natural log of a multiplied to derivative of t is 1 and derivative of 1 over t is negative 1 over t squared. So this is equation number 2 and we have obtained the derivative of y with respect to t. Now what we'll do, in order to obtain derivative of y with respect to x, all we have to do is divide 2 with 1. So that means our final value will be a raised to the power of t plus 1 over t multiplied to natural log of a whole divided by a multiplied to t plus 1 over t raised to the power of a minus 1. Here 1 minus 1 over t squared is common to both the numerator and the denominator, and that gets factored out. So this is the final value.